Okay, let's try something together. Open any world map you have available. It can be the one you find in your bookcase or even an online version. Take a look at the vast area covered by water. That's 71% of the Earth's surface. And all of that is salt water from the world's oceans. There aren't any borders between the four oceans we've all come to know, but oceanographers and the world's countries did traditionally split these waters into four distinct regions: the Pacific, Atlantic, Indian, and Arctic Oceans. And here comes the big surprise. The scientific community has recently recognized the fifth body of water. It's called the Southern Ocean, and three of the four original oceans border it. It circumnavigates Antarctica and the lower portion of the globe and reaches Australia and the southern portions of Africa and South America. What makes this ocean so special? How did the scientific community eventually recognize it? And more importantly, what mysterious creatures does it hide? Let's find out. The Antarctic Ocean, or the Southern Ocean, was first mentioned back in 1937 in the second edition of the International Hydrographic Organization's Limits of Oceans and Seas. That's a mouthful. Back then, this organization considered that it was wrong to consider the Antarctic Ocean as its own distinct body of water. Why? Well, because at that time, an ocean was defined as water surrounded by land, and not water surrounding land. However, they reconsidered it in 2000 and voted to include this ocean in the official list. They also decided on the name Southern Ocean over the commonly used Antarctic Ocean. Finally, the organization concluded that the ocean should be considered as ending at the 60th parallel south latitude. But how old is this ocean? Well, many specialists believe it to have formed only 30 million years ago, which would make it the youngest of the world's oceans. It was created when Antarctica and South America moved away from each other during the early stages of our planet's development. This unique water current is a distinctive component of the Southern Ocean, as it helps keep the waters flowing around the icy continent. It's called the Antarctic Circumpolar Current, and it moves to the east with incredible speed. It's estimated that it moves an enormous amount of water per second. Some of the disputes regarding the Southern Ocean also have to do with this amazing current. Some specialists believe it separates the water of the Southern Ocean from the waters of the nearing Atlantic or Pacific. Only the rapid circulating water is considered the Southern Ocean. On the other hand, though, a handful of scientists say that the current actually makes the naming issue more complex by not limiting the waters to a specific geographic location. They believe that the waters in the current are different in terms of composition from waters in the northern oceans because they are way colder and have a lot more salt. Sailors don't really like this new body of water, mostly because of the frequent cyclone-like storms that it experiences. They happen because of the big temperature difference between the ice packs and the ocean waves. As a result, these storms are very difficult to surpass for any sailors that happen to encounter them. I mean, really, these are the strongest winds found anywhere on our planet. More so, the vessels going through this area must also be wary of the frequent icebergs that may pop up every now and then, and also of the low surface temperatures. Just to paint you a better picture, some of the icebergs found here can span over several hundred meters and can exist all year round, regardless of the season. The latitudes from 50 to 70 have even earned the nicknames of Furious 50s or the Shrieking 60s because of these intense year-round storms. Even the landscape is unique. They say the Southern Ocean has bluer glaciers, colder air, and more intimidating mountains than anywhere else in the world. Now, let's get to the mysterious creatures that call this place home, as thousands of species of wildlife live only here and nowhere else in the world. Let's start with the quirky sea pig, or one of the sea cucumbers as it's sometimes called. There are a lot of them in the waters off Antarctica. Why is it called that way, though? Because of its pink hue and round, bloated looks. On a closer look, it even appears to have a little tail and set of ears, just like a pig. They do help a lot with the quality of the waters here, filtering sand and sediment. Then there are the Hoff crabs that live on the floor of the Antarctic Sea. The Southern Ocean is a cold water environment, but crabs are more adapted to warmer waters, So, Hoff crabs gather around the warmth made by volcanic vents. They get the needed warmth and food here. You can find them in large piles, one on top of another, literally filling the space at the vent openings. Now, wonder how they got their unofficial name? Well, it's because of their apparent similarity to the actor David Hasselhoff, whose impressive chest reminded explorers of the crab. Okay. Ever seen a fish that's completely transparent? You'd have to get to these waters down in the south, but they do exist, and they are simply called the ice fish. You can basically see inside them, being completely clear and all. That's because of their see-through skin and because they don't have any red blood cells. Their special power is that they can use antifreeze to prevent their bodies from going solid in the cold waters of the Southern Ocean. Instead of the standard thicker blood, the red one with hemoglobin, ice fish have thinner blood that moves around more easily throughout their bodies, hence giving them the much-needed nutrients and oxygen. Now, is there a monster hidden in these waters? Some people believe this to be the case, and thanks to recent research, we even have video footage of it. Some Australian researchers stumbled upon a bunch of weird-looking creatures that were swimming near the seafloor of the Southern Ocean. This pink blob-like fish seemed to be propelled by a little pair of fins. To quote them on it, it seemed to resemble a chicken just before you put it in the oven. I'm not sure I even want to know what that looks like. It took them some time and research to identify the monster. It's a shy species of sea cucumber, known more by its creative nickname, the headless chicken monster. We've known this creature has existed since the late 1800s, but we've barely ever seen it, and we've only ever captured it on tape once before when it was spotted in the Gulf of Mexico, which is quite far from the waters off the coast of East Antarctica. There's so much we don't know about this creature, like how many of them exist in our waters and how they live, eat, and reproduce. Ever heard of the emperor penguin? It's not a penguin species that just happens to have a crown on its head, if that's what you're thinking. But they are one of those penguins that inhabit this specific location and are also the largest species of their kind altogether. What makes them special is that they make their colonies on the sea ice, and most of them never step foot on land. More so, penguin dads lose almost half their weight while incubating the eggs. They're also fascinating swimmers, able to dive deeper and longer than any other bird, up to 700 feet. Not to mention they can stay submerged for up to 18 minutes at a time as they gather food. We have yet to uncover all the secrets of the mysterious Southern Ocean, but it's clear that it's home to some unique and fragile marine ecosystems. Recognizing it as a new ocean could be one way to focus the public attention on it and help its conservation. My, it's wet out here. In 2016, scientists decided to study the widest part of the Atlantic Ocean, between Africa and South America. It's kind of lonely there. They went days without seeing a single plane or ship. It was mostly just dolphins and whales swimming by. They were in the middle of nowhere. So why? They were floating right above one of the most important geological spots on Earth, the Mid-Atlantic Ridge. It's where two monster tectonic plates meet. Tectonic plates are massive jigsaw pieces that are constantly moving, even though we usually can't feel them. They form the Earth's crust, and in this case, meet beneath the Atlantic Ocean. The researchers floated over the ridge and dropped down some instruments that detect waves, earthquakes, and other vibrations. A year later, they came back to collect the results. At first, the goal was to learn more about the history of the two plates. But the instruments picked up a whole lot more than that. They found out some stuff about the future, too. Way down at the bottom, there's a layer of extremely hot liquid rock that's constantly rising up, pushing on the tectonic plates and causing them to move apart from each other. That means that the Atlantic Ocean is expanding about 2 inches every year, pushing Europe and Africa away from the Americas. At the same time, its bigger neighbor, the Pacific Ocean, is shrinking. It's the biggest ocean, right now, with a huge area that's around 30% of the Earth's surface. Its average depth is 13,000 feet and is home to the famous Mariana Trench, the deepest spot in any ocean. And yeah, It's now shrinking by around 1/5 of a square mile per year. Some scientists even believe that eventually, millions and millions of years from now, the Pacific Ocean could completely disappear. This ocean is where we think most earthquakes happen, plus it's where a lot of the world's volcanoes are. All that causes lots of shaking. Plates move around and old parts of the Earth's crust get destroyed. The ocean floor can't grow fast enough to replace it. This means some big changes are coming in the future. A couple of inches isn't exactly a big deal, but after a few 100 million years, there'll probably be a new supercontinent on Earth. Australia is slowly heading north, and it could eventually collide with Korea, Japan, and eastern China. Africa is moving too. In 50 million years, it'll be pushing right up against the southern parts of Europe. Since it's all happening so slowly, I've had a chance to think up some future scenarios. Okay, not me. A bunch of super brainy scientists with even brainier computers. The first scenario, a monster landmass called Novo. The Americas would slam into Antarctica, then they'd team up and head over to Africa. Meanwhile, Africa would have already smashed into Europe and Asia. Not bad, at least you'd save some money on plane tickets. But for most people, it would take an epic road trip to get to a beach somewhere. The second scenario is Ultima. I feel like these all sound like car names. Anyway, in this scenario, the Atlantic stops getting wider. Actually, it's the opposite. It starts closing in on itself. This new super cool continent would be surrounded by the Pacific Ocean. Scenario 3. Orica. Both the Atlantic and Pacific Oceans eventually shrink down until they either disappear or end up like tiny little lakes. All the life in these two oceans is gone. Instead, some new ocean starts forming to replace them. And the new supercontinent? It has Australia in the corner, with the Americans and East Asia each on the opposite side of a small puddle that used to be the Pacific. The rest of the planet is one big unexplored super ocean inhabited by… who knows? I won't be around then. Number 4. Amasia. There's that car thing again. This one predicts Africa, Australia, and all the continents except Antarctica start moving north. Sorry, Antarctica, even planet Earth keeps forgetting about you. Better luck next time. Well, way off in the future, it might be possible to take a big old road trip across every continent, or drive across the African-South American border, or even get to Australia without having to take the longest flight of your life. But we've got a while to wait. What should I do for the next 250 million years? Binge watch some Brightside? Tectonic plates move at different speeds, some slower, some slightly faster. Your hair and fingernails actually grow at roughly the same speed as these beasts move. Imagine if everyone lived on one of those supercontinents. Animals would finally be able to cross continents and meet species they've never seen before. Leopards, rhinos, lions, elephants. Imagine if they got curious enough to set out on a journey out of their habitat. A lion might meet a polar bear. Kangaroos could finally leave the land down under, and birds that migrate to warmer places would have to totally reorganize their travel schedules. Who knows what the climate would be like? Playing around with the continental jigsaw puzzle isn't exactly a new thing. Our world didn't always look like this. 300 million years ago, our planet didn't have 7 continents. It had only one, a supercontinent called Pangaea. Pangaea was surrounded by only one ocean. Over time, it slowly started falling apart. At one point, South America, Antarctica, Australia, and Africa were one unit, and North America and Eurasia were another. Over time, these continents also splintered off, each heading in its own direction. Scientists have discovered many similar plants and animal fossils on continents that are separated by huge oceans. Even when you just glance at a map, you can see how Africa and South America look like two massive puzzle pieces that fit together perfectly. When you look at all the oceans and seas on a map, it may look like they just flow right into each other, like there's only one big ocean and people gave different names to different parts. You wouldn't think that if you've ever been to the place where they meet. The Atlantic and Pacific have a strict border that looks like an invisible wall separating two completely different worlds. You can clearly see different colors and waters, and they don't mix. Of course, there's no wall or any actual physical border, but not all water's the same. The Pacific and Atlantic have different densities, amounts of salt, temperatures, and a whole bunch of differences. The borders that separate two bodies of water are called ocean clines. The line you see dividing the Atlantic and Pacific Ocean is mostly caused by different salt levels. This is what layers of water with different salt levels look like. It's like they're separated with cling film, each one with a different color because it has different things growing in it. To see a clear, noticeable border, one sea or ocean has to be a whole lot saltier than the other. Want to get active and use up all the salt in your house? Pour some colored salty water or seawater into a glass bowl. Then add fresh water on top. Voila! The Pacific Ocean is the less salty one. That's because there are loads more rivers flowing into it. Heavier liquids are heavy, so they should sink to the bottom. But then, why is the border between the Atlantic and Pacific a vertical line and not a horizontal one? First, the difference in density of these two salty beasts may be enough to stop them from mixing, but it's not really enough to send one of them to the bottom with the other floating above it. There's another reason, and it's all about the Earth spinning around. Say you're flying from Chile to New England. If you fly straight north, by the time you get there, the Earth will have turned a bit, and you'd be nowhere near your destination. To get to the right place, the pilot needs to fly in a bit of a curve. That's sort of the same reason that currents move around in different directions. The currents in the Atlantic and Pacific Oceans move away from each other, so they don't really mix at their border, even though they're both just water. Confused? Yeah, me too.
When you look at the seas and oceans on a map, you might think that they just flow into each other. Like there's really only one big ocean and people just arbitrarily gave different names to its different parts. Well, guess what? You'll be amazed at how much more substantial the borders between them actually are. For example, the border between the Pacific and Atlantic Oceans is like a literal line between two different worlds. It looks like the two oceans meet at an invisible wall, which does not let them flow into each other and mix their waters. Why on earth does that happen? Obviously, there's no actual invisible wall inside, and water is just water. So what could be interfering with its mixing? Well, the thing is that water isn't just water. There can be different kinds. The Atlantic and the Pacific Oceans have different densities and chemical makeups, the level of salinity, and other qualities. One can see by their color that they are far from the same. Borders like this, between two bodies of water with different physical and biological characteristics, are known as haloclines. Jacques-Yves Cousteau discovered one of them while he was deep diving in the Strait of Gibraltar. The layers of water with different salinity looked like they were divided with a transparent film, and each layer had its own distinct flora and fauna. Haloclines appear when water in one ocean or sea is at least 5 times saltier than in the other. You can create a halocline at home if you pour some seawater or colored salty water in a glass and then add some fresh water on top of it. The only difference is that your halocline will be horizontal and ocean haloclines are vertical. For those of you who were paying attention in chemistry class, you might remember that if you have two liquids with different densities in one space, the denser liquid should eventually end up below the less dense one. By that logic, the border between the two oceans should look not like a vertical line, but a horizontal one, and the difference between their salinity would become less obvious the closer they got to each other. So, why doesn't it work like that? Firstly, the difference in density of the two oceans is not big enough for one of them to sink down and the other one to rise up, but it is big enough to not let them mix. Another reason is inertia. There's an inertial force known as the Coriolis force, which influences objects when they are moving in a system of axes, which in turn are moving as well. In simpler terms, the Earth is moving, and all the moving objects on it are carried along, acted upon by this Coriolis force, deviating slightly from their natural course. As a result, the objects on the Earth's surface don't move straight on, but deviate in a curve, clockwise in the northern hemisphere and counterclockwise in the southern. But because the Earth is moving slowly, after all, it does take the planet a whole day to make a full circle around its axis, the Coriolis effect isn't easy to observe in the short term. It becomes easier to notice only in long-term intervals, like with cyclones or ocean flows. And this is why the direction of flows in the Atlantic and the Pacific Oceans is different. This difference also doesn't let them mix. Another important difference between these two ocean waters is the strength of molecule connection, or surface tensile strength. Thanks to this strength, molecules of the same kind hold on to each other. The two oceans have totally different surface tensile strengths, which also doesn't let them mix. Maybe if the waters were completely still, they could gradually start mixing over time, but as they flow in opposite directions, they just don't have time to do this. We think that it's just water in both oceans, but its separate molecules meet for just a very short moment and then get carried away with the ocean flow. But if you think that it's only the Atlantic and Pacific Oceans that don't get along with each other, you are sorely mistaken. There's lots of places on the planet where the waters of the two seas or rivers don't mix, and for even more weird reasons. For example, there's a different kind of border called a thermocline. These are borders between waters of different temperatures, like between the warm water of the Gulf Stream and the much colder North Atlantic Ocean. But the most interesting kinds are called chemoclines. These are borders between waters having different microclimate and chemical makeup. The Sargasso Sea is the biggest and most widely known chemocline. It is a sea within the Atlantic Ocean, which has no shores, but is very obviously distinct. You can't not notice it. Let's now take a look at some other spectacular clines we have on planet Earth. And just as a heads up, I might mispronounce some of these names coming up, so please forgive me. First up, we have the North and Baltic Seas. These two seas meet near the Danish city of Skagen. The water in them doesn't mix because of different densities. Sometimes you can see the waves of the two seas clash into each other, making foam. Their waters do mix very, very gradually. That's why the Baltic Sea is slightly saline. If there had been no water coming to it from the North Sea, it would have just been a freshwater lake. Next up, the Mediterranean Sea and the Atlantic Ocean. They meet at the Strait of Gibraltar and have both a different density and salinity. So there's two reasons their waters don't mix. Then we have the Caribbean Sea and Atlantic Ocean. The place where they meet is near the Antilles, and it's very easy to spot. It looks like someone has painted water with two different shades of blue. Another place where these two meet is Eleuthera Island of the Bahamas. The Caribbean Sea water is turquoise, and the Atlantic Ocean water is dark blue. There is also the Suriname River and the Atlantic Ocean, which meet near Paramaribo in South America. How about the Uruguay River and its afflux? These two meet in Misiones province in Argentina. One of them is claimed to be used in agriculture, and the other has an almost red tint to it because of loam during rainy seasons. Here's an interesting one: the Rio Negro and the Solimões rivers, part of the Amazon River. 6 miles from Manaus in Brazil, the Rio Negro and Solimões rivers flow into each other, but don't mix for about 2.5 miles. The Rio Negro is dark and the Solimões is light. They have different temperatures and speeds of flow. Then there's the Moselle and Rhine rivers, which meet in Koblenz, Germany. The water in the Rhine is lighter than that of the Moselle. Okay, how about 3 different bodies, like the Ilz, Danube, and Inn rivers? The junction of these 3 rivers is in Passau, Germany. The Ilz is a small mountain river to the left, the Danube is in the middle, and the Inn is a light river to the right. The Inn is wider than the Danube here, but is still its afflux. Take a look at the Alaknanda and Bhagirathi rivers, which meet in India. Alaknanda is dark and Bhagirathi is light. I really hope I got those right. The Irtysh and Ulba rivers flow into each other in Kazakhstan, near the city whose name is Ust-Kamenogorsk. The Irtysh has clean water, and the Ulba's water is cloudy. Moving further east, the Jialing and Yangtze rivers meet in Chongqing, China. I really hope that's close at least. The Jialing is clean and the Yangtze is brown. The Irtysh River actually has another intersection with the Om River. These 2 rivers flow into each other in Omsk, Russia. Here, the Irtysh is cloudy and the Om is pure and transparent. Speaking of Russia, the Chuya and Katun rivers meet in the Altai Republic. The water of the Chuya has an unusual cloudy white color here and looks dense and thick. The Katun, by contrast, is clean and turquoise. Flowing into each other, they form a single two-colored stream that does not mix for some time. On the other side of the globe, we have the Green and Colorado rivers. The place of their junction is National Park Canyonlands in Utah, USA. The Colorado River is brown and the Green is, well, green. The corridors of these rivers go through rocks with different chemical makeup. That's why they have such a big contrast of colors. Last, but not least, we have the Rhone and Arve rivers. They flow into each other in Geneva, Switzerland. The Rhone is a pure river that flows out from the lakes of Geneva, while the Arve is cloudy and gets its water from the glaciers of the Chamonix Valley. This is by no means an exhaustive list of all the strange climes on our beautiful planet, but as you can see, it happens a lot more often than you think. These are the kinds of environmental oddities that can really teach you about the way the natural world works. If you're curious enough, of course. Thanks for watching. Oh, and let me know how well I did with the pronunciations. Constructive feedback is always helpful.